Hi, it's Alex here again. Now, here we are looking into the further examples of the design of shaft due to the combine of bending and twisting. So now here we have a question. Now a shaft with a gear is mounted on bearings as shown in the figure below. The gear is 125 mm in diameter, or the pitch circle diameter of the gear is 125 mm, and 3.7 kilowatt of power are transmitted at a speed of 120 revolutions per minute, assuming an allowable shear stress of 42 megapascal. So when you look into this question, now due to combined bending and twisting, when the question has given us the allowable shear stress, the best is to consider the equivalent twisting moment, that is the TE, to find the diameter of the shaft. Now here's the diagram given. So you have the tangential force that's acting on the gear. Okay, so the tangential force gives us the torque when we take the tangential force multiplied by the pitch circle radius, or the radius of the gear. Okay, so power transmitted, first thing is power transmitted can also be determined from the power formula below here, where the speed is given as 120 revolutions per minute, and the power is given as 3.7 kilowatt. Okay, so from this equation here, we can find out the torque transmitted is equals to 294.4 Newton meter. But at the same time, as the gear rotates, it also produces a couple, or a turning moment, or a moment about the shaft at where the gears are located, where the gear is located. Okay, so from this, actually from the torque, which is tangential force times radius, or diameter over 2, okay, we can find the tangential force is actually equals to, now this is the torque, 294.4, this is the diameter of the gear, which is given as 125 millimeter, so into meter it will be 0.125 here. So from this we will be able to find out the tangential force of 4710.4, and at the same time from this we can also find the bending moment, the moment that is acting, or the bending moment that is acting on the gear itself at the section of where the gear is placed on the shaft. So from this, we also know that the moment or the couple at that point is equals to tangential force multiplied by radius. And from this, we will be able to find out the moment as well, which is equals to 294.4 Newton meter. So as according to the previous equation or the formula that we have defined, or we have proved, that in order to find TE, we have to have the torque and the bending moment as well. So from this, we will be able to find the equivalent twisting moment by substituting the moment, which is 294.4 power 2, plus the torque, which is also 294.4 power of 2, we will be able to find out the equivalent twisting moment of 416.3 Newton meter. So, and again from the TE, we can also say that it is equal to pi over 16 times diameter to the power of 3, then times with the maximum shear stress, which is given in the question as 42 megapascal. So from this, we will be able to find out the required diameter of shaft in order to transmit 3.7 kilowatt of power. So the diameter is found as 37 millimeter. And that's all for this section, for the slide, for example 6. So if you have any comments or questions, please put on the comment section in my YouTube under shaft design. Thank you very much, and see you all soon. Bye bye.